Alright people, so welcome back to another video in our Mitre-Attack series. Today we are going to finish the encrypted channel technique. Second sub-technique of it is Asymmetric Cryptography, here 002. So let's get into the overview here real quick. So as you can see, we are in the command and control tactic, and still we have our operating systems affected, ESXi and network devices. Here I noticed that for none of the encrypted channel techniques there was a name, so nobody took credit for that. Nonetheless, the detail, or let's say the quantity of information, was pretty good. The quality of as well, I didn't notice anything. So I think there might be room for improvement here as well, or just add a layer of depth and put your name onto this. Be a great achievement, I believe. Yeah, let's see what they write here about asymmetric encryption, and there are further ways of encryption, by the way. So you have symmetric, asymmetric, but you have also the hybrid encryptions out there that use both a little bit. So you have multiple variants, but if you know symmetric and asymmetric, you know like the important chunk of encryption out there. That should be sufficient to detect or to have an idea of what to detect when it comes to hacker defense. Now let's read. Adversaries may employ a known asymmetric encryption algorithm to conceal command and control traffic, rather than relying on any inherent protection provided by a communication protocol. That's the same sentence as from our from the technique. Instead of relying on SSL that is provided by certain communications that you use that are already there in the target company, you can additionally encrypt it. Then it says asymmetric cryptography, also known as public key cryptography. Yes, that's a good indicator. Private key and public key cryptography, this is how you can call it as well. And if you are interested in the mathematics behind it, you might want to read some computer scientists courses on that. So at universities they teach that kind of stuff. It is fairly interesting, but you should be a little bit into mathematics. So you dig into the logarithm and, or not logarithm, the log, like cyclic groups is the mathematical term of this. Logarithm is not used, but this way of saying, for example, 10 log 20 or so, this is like the knowledge behind that you will see a lot. And prime numbers play a huge role in public key cryptography as well. So it is fairly interesting from a mathematical standpoint of view. So if you are into that, just look up some of the universities. There are free material out there from the big universities usually on that topic. I think also the channel number file, this mathematician channel on YouTube, I think they covered that as well at some point. But yeah, then use a key pair per party, one public that can be freely distributed and one private. Yes, the public one is used for encryption, the private one is used for encryption. That's how it works. So you have two keys usually. As a result of that, you can just show everybody the public key, even the hackers. Well, what can they do? Encrypt some message? They wouldn't be able to decrypt it, and nobody except you would be. And then, due to how the keys are generated, the sender encrypts data, or here it says with the public key and private key. Yes. This ensures that only the intended recipient can read the encrypted data. Common public key encryption algorithms include RSA and El-Gamal. Those are the classics we learned at university. Yes. RSA algorithm. This is Rivet, Shamir, and Edelman. These are the names of the inventors. El-Gamal, I'm not sure. This might be the name of the mathematician. This is the name of the mathematician for sure. They are pretty close to each other. El-Gamal, as far as I remember, is like a little bit more sophisticated in terms of the mathematical concept, But RSA is also, they are fairly simple too, so you can calculate them on paper with really small numbers. The computers, they use then 1,000, 2,000 bits for that. So nothing for the paper anymore, but the base, the core concept be executed, and we had to do that in our exams. So there was like a key pair and whatever, and they said encrypt that number now, the following parameters. It was quite something. Yeah, and then for efficiency, many protocols include SSL TLS, including, yeah, they use symmetric cryptography once a connection is established, but use asymmetric cryptography to establish or transmit a key. And this is what I meant by hybrid. This is like the hybrid cryptography basically. And also keep in mind, asymmetric encryption or public key is not efficient at all. Your CPU has to calculate a lot, and takes the factor, I think, 100 times more computation for the same data comparison to symmetric cryptography. There are benchmarks out there, but it's like 100 times as much, so you can feel that in high performance applications for sure. Alright then, let's move on to procedures. So here will be nothing exciting. There are more than just that, but here you will have just a whole bunch of hacker groups and software that is using some sort of asymmetric encryption here. It's just yeah, I see a lot of APTs. I don't recognize Biscuit we have seen. Carbon, maybe. And some of the APTs 42 we have seen too. As you can see, it is used by the hacker activities out there. That's the key takeaway of this slide. Let's move on to mitigation then. So again, you can have a network intrusion and prevention system in place. These are looking for signatures. We'll have like network signatures. This is hash based typically, and they might detect something. It's not a 100% detection. So if just a slight tiny bit of the encryption is changed, the signature will be different and won't be detected. So yeah, it's never ending fight. With antivirus systems work the same, right? They had like a hash of a virus, but if the virus slightly changes, the entire hash value is different and no longer matches. And then of course you can do SSL TLS inspection at this point. So this was not a topic with the symmetric cryptography, so the last sub-technique we covered, but here this would be possible again. Well, if you have the key, obviously. You can only inspect SSL TLS, you can decrypt it, and not sure to what extent you can inspect anything if you don't have the private key at hand. But yeah, that's the mitigation here. Detection is again similar to the other two that we covered, so look out for anything that is not typical and that tries to encrypt with asymmetric crypto libraries. So here would not be looking for AES in the libraries, you would be looking for these ones here. Libraries, Crypt32 and RSA is the name, so detect those. If you look further down, it's again detect some sort of RSA or key exchange behavior of a process. This is what you should look out for. Also TLS, those. So everything that looks like typical asymmetric encryption, you can detect that at your SOC if you have the right logs from the systems, operating systems, or you have process logs. Here we see again, just monitor Python, Bash binary scripts that are somehow loading other libraries that are used for encryption. This stuff can be detected. The difficulty here is that your administrators, they will also use these tools, and it's a great fun distinguishing a hacker from your admins. You also don't want to bother your admins too much with asking them what they are doing there, so it's not that easy to detect the false positives there. Now let's take a look at the references. So here there are a lot of references as well. I took the first ones here. let's see if we can find any names that catch our eye. So we have Bitdefender here, APT28 under the scope, right? Mandiant Group, also very popular, very capable. There are some great experts out there. We have Accenture, the big consulting companies. So Turler uses Hyperstack, Carbon, Kazua to compromise government entities from 2020. 5 years old. Yeah. Checkpoint, okay, that's a firewall. Ransomware alert, pay to key. 2021. Ransomware is still a big problem. Mercer, I've seen multiple times by now, so it appears to be a great researcher. We might want to take a look at one of the papers. Mercer, as we see that name so often. We might look at that. Yeah, the other ones are not familiar to me, but that's fine. So also let me know if you see something here that catches your eye. Yeah, so then we are through with the encrypted channel asymmetric cryptography. Thank you for watching. As usual, thank you for spending time in cybersecurity. This time well spent, and see you in the next video then. Goodbye.